Hello Chemistry, this is the video that goes along with Lab 30, Heats of Reaction. In this lab we're going to do 3 experiments where we measure or investigate the heat of combustion, the heat of solution, and the heat of neutralization. Okay, so we're going to be measuring or manipulating delta H in these reactions, which is the kilojoules or the energy involved in a reaction per mole of the reaction. Okay, so that's what we're doing right now. The first one we're going to do is the heat of combustion. You did this, you did the calculations for this in a pre-lab already, where you took 2 milliliters, which we've measured here, of different alcohols. The one that we have today is methanol, and you calculated using the heat of combustion how many joules of energy can be released from burning this 2 milliliters of methanol. We spent a lot of time doing that in the pre-lab. All right, today we're going to release that energy, and we're going to try and funnel the energy into an object that we can measure the temperature of, okay? So my methanol, my 2 milliliters of methanol is in my ceramic dish. I'm going to place it underneath the beaker of water, like that. All right. Right now we're measuring the initial temperature of the water. This is 200 milliliters, like it says in your lab report. And the initial temperature here is 24.8 degrees Celsius right now. Okay, so it's 24.8 degrees Celsius. We are going to go ahead and light it up and see what we get. Okay, so hopefully the temperature should increase. So you can't really see the flame under there, class. I'm going to turn the lights off so that you can see the flame a little bit more clearly. Hopefully this shows up on the video here that you can see there's a small amount of blue flame burning under there. And you can also see the temperature is going up as we burn this methanol down in that can. Okay, the tin foil on the outside is supposed to funnel all of the heat into the bottom of the beaker. Okay, so let's see how hot we can get this as we burn this methanol. I'm actually going to bring the camera a little bit closer here so you guys can see this flame a little bit more clearly. All right. See below there, that is the methanol burning down below, right? It's hard to see from far away, but you can see it now, right? It's burning inside that dish. We're almost done. The flame looks like it's about to go out, but we're just going to sit here and wait for all of the methanol to combust as we measure the temperature of the water here. Okay, it's still... Our class, it looked like the maximum temperature there was about 38.5. If we come down here and look, we can see that there's no more alcohol. I'm going to grab some tongs here and pull this out. If I can, maybe. Let's see if I can pull it out. If we look on the inside, it's pretty hot. But if we look on the inside here, we can see the methanol's all gone. Okay, so about 38.5. Oh, actually, now it looks like it's gotten up to about 38.6. We'll call that the maximum temperature there, 38.6. Okay, so you should have marked down what temperature it was initially. Now it's at 38.6 for the maximum. All right, it's going to start slowly kind of going down here over time. Experiment, right? This was our heat of combustion experiment. Hopefully, I'm just going to rinse this probe off in some distilled water and move this just kind of over to the side. This, and we're going to pull out experiment number 2. All right, now in this experiment, we're going to be measuring the heat of solution here. I've measured out our 200 milliliters of tap water in our calorimeter. And here I've got 3 grams of baking soda. Okay, so we'll measure the initial temperature, let this kind of sit in the water here for 30 or 40 seconds while we kind of clean. Okay, class, this is probably a good baseline temperature here for the initial temperature of the water. I'm going to dissolve my 3 grams of baking soda, or sodium bicarbonate. Chemical formula is sodium, 1 hydrogen, 1 carbon, and 3 oxygens. Okay, so we're going to dissolve this and watch what the temperature does. Okay guys, that dissolved pretty quickly. It looked to me like the minimum temperature here, oh, there's going down a little bit more. Maybe 22.5, let's see if it goes down any more, if that's the minimum temperature here. Okay, yeah, it looks like about 22.5 is the minimum temperature. Right, hopefully you see there that when we did this, the temperature went down, all right? So the first experiment released heat, right? And we saw the beaker get hot, right? The surroundings get hot. That's an exothermic reaction that has a negative sign for delta H. Now this reaction got cold, meaning the molecules sucked energy in from the water, and so that means you should have a sign that is positive here on the delta H of solution. This is an endothermic reaction. Heat goes from the water into the reactants, okay? You need to calculate the heat of solution here in kilojoules per mole, and if you follow the analysis, you'll be able to do that. Okay? All right, guys, I'm gonna rinse this off again. We don't contaminate our reactants, and I'm gonna get our third reaction. Here, I've put a concentrated base in my calorimeter, 100 milliliters of it, and I've got 100 milliliters of 0.2 molar hydrochloric acid, and this is the limiting reactant. This is the one that's going to tell you how many moles actually reacted. Listen to that again. 0.2 molar, 200 milliliters. You can use the molarity formula to come up with the moles of acid here. All right, we're going to mix these together. It's going to create a solution with a total volume of 200 milliliters, and you will use that solution to determine how many kilojoules were either released or absorbed by the reaction. Okay, so let's find out. We're going to add this. Oh, first off, almost forgot. We need to put this into our base, like this. All right, we just need to let this kind of come to equilibrium temperature here. These have both been sitting out at room temperature for a long time, so they're both about 23.4 before we mix them, okay? All right, it's time to go ahead and add and see what happens. That's our base temperature right there. Okay, so here, 24.7 looks like the max right now. The temperature went up. Think about what that means in terms of delta H. Right? What should the sign be? Is this an exo or endothermic reaction? Right? You will need to calculate the kilojoules either absorbed or released by this solution, this water here, by using the temperature change, by using the mass of the solution, that should come from 200 milliliters of total solution, use the specific heat of water, right? Use that and the moles of acid to calculate delta H. It's all in the analysis. Make sure you carefully read through and answer the analysis questions. If you have any questions for me, I'm around. Remember, this lab has to be completed on your own. All the labs are due on Monday, okay? So they're all due on Monday. I will see you then for the last week of school.